Welcome to Semiconductor News Decoded. I'm Ty, with 31 years inside the semiconductor industry, bringing you the real view from the factory floor. Today's topic: can a castle town actually grow up around Rapidus? In Chitose, Hokkaido, a local company called FJ Composite is preparing to mass-produce heat dissipation materials for AI chips, with Rapidus squarely in their sights. We'll also touch on Samsung narrowly avoiding a strike and on yield improvements at Intel's 18A process.
As always, I'll explain everything in the most simplified way possible. Even a middle schooler should be able to follow along. If you're a specialist watching, some parts may feel oversimplified, but I'd like to prioritize giving everyone the big picture first. Today, the analogy we'll lean on is a castle and the castle town around it. So sit back and enjoy. Here's today's news in one picture. We'll lean on this castle and castle town analogy all the way through the opening section. Imagine the middle of Hokkaido, a town called Chitose. One day, out of nowhere, an ultra-high-tech castle is built right there. This castle is Rapidus. It's a semiconductor castle that carves circuits at 2-nanometer scale. That's tens of thousands of times thinner than a single human hair.
But think about it for a moment. Just because a castle has been built, will the land around it actually prosper? Inside the castle, lots of people work every day. They want food, they want clothes, they want their tools repaired. If the castle just stands there all alone, that by itself doesn't make a town function. That's why, since ancient times, a castle town was always built around every castle. The greengrocer, the butcher, the blacksmith, the saddler. Merchants and craftsmen who supply the castle gather around it, and only then does the land start to truly flourish. In semiconductors, the structure is exactly the same. But right now in Chitose, the castle has been built, but the castle town isn't there yet. Almost no local Hokkaido company has raised their hand and said, "We'll supply the castle." That's because the parts and materials this castle needs are simply too advanced. That's where the Hokkaido prefectural government has stepped in. They've started holding seminars in Sapporo, inviting expert merchants from Tokyo and the Kansai region, people who already know the chip business, to come and teach local companies how to do business with a castle like this. For now, the Hokkaido side is still very much on the learning side, on the listening side. And then, a local Chitose company quietly raised its hand. "We'll be the first inhabitant of the castle town," said FJ Composite. Their specialty is solving one very specific problem that's happening inside the castle, and that's the real main character of today's story. Inside the castle, they're cooking the newest dish in the world, AI. And this dish gives off an enormous amount of heat. If you keep cooking at full flame, the kitchen turns into a furnace. So you need a fan craftsman to cool things down. FJ Composite is exactly that, a high-tech, semiconductor-specialized fan craftsman. In other words, a heat dissipation materials maker. From here, let me walk you through what this actually looks like in the real semiconductor industry. FJ Composite is an electronic components maker based in Chitose. They already produce heat dissipation materials called SCMC and SDBC, specially structured materials with multiple layers of copper and molybdenum stacked together, used widely in 5G base stations, cellular base stations, in-flight Wi-Fi equipment, and heat sinks for semiconductor packages. They've now announced a plan to mass-produce heat dissipation materials specifically for AI in earnest. The target is to start mass production by 2029 at an annual revenue scale of around 5 billion yen, and they're explicitly looking at supplying this material to Rapidus. As a local company, they're consciously aiming to become the first resident of the Rapidus castle town. Why is heat dissipation so important? AI semiconductors handle a massive amount of computation, and their power consumption is on a completely different order of magnitude from before. If you use electricity, you generate heat. If you generate heat, the chip breaks. So today, how do you cool it down has become just as important a competitive axis as how fast can you compute. It really is a battle against heat. Chitose City itself is also moving. They're developing a new industrial park in the Kashiwadai district, about 45 hectares total, spread across A, B, and C blocks. Pre-reservation sales start in fiscal 2026, and Block C will go on sale in fiscal 2028. The city is preparing the land for the castle town ahead of time. On the talent side, Chitose Institute of Science and Technology, a public university, joined LSTC, the leading-edge semiconductor technology center, as a member in 2025. The school that trains young people studying semiconductors, a key building block of the castle town, is also taking shape. Land, talent, companies. Piece by piece, the elements are starting to come together. In December of 2025, a semiconductor industry entry promotion seminar was held in Sapporo. The speakers were Sangyo Times, Somar, Jet, Resonok, and so on, but almost all of them were companies from outside Hokkaido. Local Hokkaido companies are still in the learning side, negotiating side position. From here, my own view. For a local small or mid-sized company to directly enter 2-nanometer leading-edge chip manufacturing is frankly extremely difficult. The technical bar is just too high. But a semiconductor fab generates a huge amount of peripheral work around it. Equipment parts, metal processing, resin processing, control panels, wire harnesses, chemicals, gases, piping, ductwork, maintenance, industrial waste processing, back-end and packaging materials. The real fighting ground for local companies is right here. FJ Composite isn't involved in the front-end 2-nanometer chip manufacturing itself, but on the back end, mounting the chip onto a substrate, channeling heat away, preventing warping and cracking, keeping it running stably for years on end. They're the unsung lead. Quiet, but absolutely essential. That's the position they're carving out as the first resident of the Rapidus Castle Town. Let me touch on a couple of other news items as well. Over in South Korea, Samsung narrowly avoided a strike that had been announced 18 days in advance. It was right on the edge of impacting HBM and foundry production. So from a supply chain perspective, this is a small but real sigh of relief. And there are reports that Intel's 18A process is showing yield improvements. For a while, the picture there looked rough, but a path toward mass production is starting to come into view. For Rapidus's 2-nanometer effort, 18A is a global competitor process, a rival to keep watching closely going forward. Now for the conclusion. From a Japanese industry perspective, Japan's semiconductor comeback needs more than just Rapidus, the castle. It absolutely needs the castle town around it. Hokkaido is still in the dot stage. The Kashiwadai Industrial Park as the land, Chitose Institute of Science and Technology as the talent, FJ Composite as the first concrete example. Whether they can connect these dots into a line and grow that line into a plane, an actual industrial cluster, is what's truly at stake. The real contest starts right here. That's all for today. I'll keep bringing you semiconductor news and analysis, so if you found this useful, please like, subscribe, and I'll see you in the next video. This has been Tai on Semiconductor News Decoded.